Oh my God, Windows. Okay, first fail. What does that do? Hey. Hello, everyone. My name's Ian. I have feedback. I work for Elsevier. I am an operations manager in one of the verticals which look after the infrastructure and operations within Elsevier. We are going to talk today about taming the chaos through automation. So I guess I'll start off and try and explain what chaos is, or what our particular flavor of chaos is. So, oh, by the way, just to say, so I'm going to do all the fluffy stuff because I'm a manager and don't really understand any of this shit. And James is going to do all the technical stuff. So this is how it's going to work. So, yeah, so I suppose sort of like a typical development house setup is, if you're in AWS, we're pretty much all in AWS. We have been going through a 3-year transformation project to move from all of our data centers into AWS, and we're about 75% of the way through that. I can't actually tell you what our AWS spend is, but it's big at the moment, but and going to get bigger. So if you've got a typical development house AWS setup, you might have something like this. You've got a number of different dev teams, and they are maybe that's going into their AWS account, and in their AWS account they might have a production VPC and a non-production VPC, and inside that they will have a number of different environments and eventually a production environment. And that's all kind of quite simple, you know. It's not particularly difficult. I do hate Windows.
Or just computers.
Oh, maybe it's just computers. Yeah, there you go. That's true. That is. Yeah. How do you scroll up in my notes? Good Lord. Macs are so much better. Could I just say Macs are... no. Otherwise, get into the Puppet Ansible thing in a minute, so that probably won't be good. Yeah, so it's fairly straightforward. One product, one end goal. You know, everything's got to work because it's got to go through an integration or something like that. So, you know, it's fairly easy to run configuration management or infrastructure as code tools. Our setup's a little bit different. We have a single dev team, which will have a non-prod account and a production account. And in the non-prod account, we'll have multiple VPCs, which the environments are split into. And then we'll have in the production account, we'll have a production VPC. Again, you can look at it, 2 accounts, you know. I mean, that still looks quite simple, really. You're thinking, well, where's the chaos in that? Except we don't have one dev team. We have quite a few more dev teams. We have, and they're all of them have, a dev team will have 2 accounts at least. They'll each have several VPCs in each account, and they will each, all of them, working differently or whatever, and off they'll go. But the thing is, we don't actually have just a few more. We have a lot more. A huge amount. So we've got all these accounts, all these VPCs and everything. And so our estate, we've got about 40 independent development teams, and by independent, I mean almost fanatically independent. You know, if they find that someone's doing something, they will find another way to do it. I mean, if they find that the person next to them in their own team is doing something in one way, they will find another way to do it. It's just the nature of the way they like to work. Each development team has got 2 to 3 AWS accounts. Each account has got between 1 and 6 VPCs in it. That gives us a grand total. My team is currently looking after about 90 AWS accounts and 300 VPCs. That's the chaos, if you like. It's a lot of... so, you know, the headache for us, it's not this one product going one way and there's an end goal which is the same for everybody. It's very much that we have all these different accounts, people wanting to do things in so many different ways and everything, and, you know, how do we manage this? You know, how do we build all of these that that deliver the development requirements, I use that word with air quotes, use the development requirements, give them that, but it's manageable. It's all done in the same way. There's not all these different special snowflakes and so on. And another thing, how many operations people do we have to manage all this? Any guesses? Yeah, it's just James. He is actually just James. It is incredible. I'm going to give him a pay rise, I promise. Yeah, so how do we manage it? So, I mean, all the development teams, they all believe that they've got different requirements. They haven't really. 95% of them are running Java. They're just Java apps. They're, got a presentation layer, they've got a Java middleware layer, and they've got some database backend, whatever it might be. And obviously, why have one database if you can have 6 and all this sort of thing? So we've worked really hard to deliver our stacks in using exactly the same building blocks. So what we've done is we've built our infrastructure deployment is done through Terraform, and we have done it in a way that it is building blocks. So the idea being that you can take all the different building blocks and fit them together, and like Lego. From Lego you can create whatever you want, a Batman or I don't know, whatever. And this is what we try to do. We use dry principles. We don't. All of our modules, a developer comes along, they've got a Solar module, they want to use Solar, well, we have a Solar module that does that. We make sure that the module itself is absolutely static, and it is just changed by variables. And James will go into a lot more detail about Terraform and how we do that, like I say, in all the technical stuff. So, I say everything is our code is very solid, and we try and make everything exactly the same, even though when you put them all together, you end up with lots and lots of different things. Our accounts, all these accounts, we use Cloud Health as our for our cost management. We've only just started using it. It's kind of okay. I did spend 2 days last week trying to figure out reserved instances with it, and I thought, I'm going to be about 10% out. I ended up, I was to a factor of 10 out of where I needed to be, and so jury's still out on Cloud Health, but yeah. We have dedicated accounts team. They manage the accounts. They build them for us. They've set them all up and everything. We have a very good relationship with AWS. We have optimization managers who look at things like RIs and how we can better, make use of what we've got and do it in a more cost-effective way. And we use things like enterprise accounts that consolidate VPC flow logs and security logs so that we don't have to go to every single account to look at things. Oh, I do love Windows, sorry. There we go. And our VPCs, modular Terraform, like I say. James will go into more detail in this. We use VPC bootstrap modules where they reference everything. They pull in linked other modules as building blocks, and there is a really distinct separation of data and logic. For those of you who've used Puppet, think Puppet and Hiera, how that separates data from the logic of the modules, and that's exactly the same. Oh God, I hate Windows. That's exactly the same as what we use in our Terraform. Yeah, so number of people. Like I say, and our working strategy. So we're constantly working on lowering the barrier of entry. So one of the things that we can't do as an operations team, there's no way that we can service these 1,000-odd, I think it's about 1,500 developers with all their different requirements and so on. So we've written all of our stuff to lower the barrier of entry so that anyone can pick it up, in effect. We need to we need everyone to be able to use this, and there's no point writing all this stuff if people don't use it. The best and easiest solution, we want this to be the best and easiest solution for their infrastructure challenges, and so we work with them to lower the barrier of entry. We want the development teams to own their own infrastructure. We very much, although we are the owners of the infrastructure, we very much, we're responsible for it in terms of cost and in terms of how it's set up and getting the best operational maturity and best practices through. We need them to own it. But if you let a developer loose in AWS, then, Elsevier would be bankrupt within a month, let alone, we'd have something which just, I just opened up all the ports because I wasn't sure which one I needed, and you know how it is. So you can't do that through. Please don't. Please make sure you use security groups. Please make sure you do this. No, you have to do it through your technology, and that's what we've worked very hard to manage. We also have some ops engineers that sit inside dev teams. So I have quite a lot of my ops people. They don't sit with us. They sit within the dev teams. They are very much part of the dev teams, but like a UX designer or whatever whose responsibility is to champion UX stories in the backlog and through the sprint planning and so on, their job is to champion operational maturity and to help people use the platform. And we provide a consultation service. So, we can say, look, here are our tools. If you're going to use them, come and speak to us. Weekly meetings, code reviews, and it's a feedback loop. If our tools do not do what people need them to do, then people are not going to use them. And that's what we really have. We work very hard on making sure that I know I've thrown a few jokes about developers out there, but we do work very hard to collaborate with the developers that we've got. Oh, God. And so we've got an ops team of about 20 people for all this, which... where were we? We were at the New Relic conference, and they had one ops person per 30 developers. Yeah, which would, and they were really proud of that, and we were like, yeah, we'd love that. That'd be really nice. This is you, James. Yeah. This is you. So I'm going to hand over to James now. Like I say, he'll give you the more meat on the bone, but this strategy of building blocks and the ability to allow anyone to use our technology in a collaborative manner means that we're an ops team that has a huge estate, but a very small ops team to do it. So I shall hand you over to James. Don't talk into it, because it's really picks up quite well.
Where does that go?
I don't know.
If I do that, no. Can people hear me?
Yep.
Sweet. It's not that hard. So if you're looking for kind of a big in-depth code thing, I'm not really going to go into that. If I had one account, it would be super easy for me to automate the crap out of it and show you how I can spin up VPCs and EC2 instances, auto-scale, deploy. So I'm going to go through some of the principles of why we chose it and some of our patterns. So why Terraform, and what did we do to get on it? Everything we do a proof of concept phase. So they last about 2 to 5 days, depending on size. With this one, we did CloudFormation, Asgard, Terraform, and Troposphere, if anyone knows Troposphere. We didn't look at Ansible, because I like to keep a separation between the infrastructure and configuration management. Using something like Ansible to do Amazon deploys, it just muddies the water. It gets confusing where the line is. In my opinion, which Iain agrees with me on. Terraform's cloud agnostic, really helpful for us. We're Amazon first, but we do have some cases to have DR backup, special snowflakes where we need to have other servers in other places. Using it, we can write the same language, same principles, and use Azure or something like that. Stored in version control, it's pretty hard to do automation without that, so we pretty much dismissed Asgard as soon as possible. For us, it was a no-brainer, but we still looked at the idea because we have a lot of accounts that have stuff in it already. Asgard, at the time, did provide at least a way to manage that without having to kind of retrofit in. Low barrier to entry. So, as Iain said, we're not that many people. We want other people to do the work. And so, having something that was easy to kind of develop, to kind of onboard people with was kind of key to us. If you have some management experience, it's pretty easy to get a grip of Terraform. Documentation is great. Oh, crap. But with that in mind, like, Terraform might not be the best thing for everyone. But when we're working at scale, we have to kind of realize kind of what the requirements are before choosing. It's, you know, in our circumstance, we need something that scales really high, but if you have 1 or 2 VPCs, another tool might be all right, but it's understanding the requirements before kind of going ahead with it. So what was the design approach? At first, there probably wasn't that much, but as we started going forward, we had to think about it quite heavily. So, as Iain mentioned, we've got a really highly modular setup. So we have things called core modules. They're developed by the core team, which is myself and a few people. They're approved. It means that what you're getting is, you know it's going to work. We've designed it properly. We try and design them to work for as many people as possible. It doesn't help us if it works for one team, not the other. So we have lots of required variables, lots of, you know, optional variables. We try and make them work for everyone. All modules will always build everything it needs to run. So Solar, for example, it will build every resource it needs to run itself. The only exceptions to that is subnets, NACLs, which we have in another module. We have those to stop developers doing stupid things like opening up ports. We have rules to stop kind of silly traffic. And with that kind of approach, if someone decides to bin their Drupal or whatever, we run Drupal, it's disgusting, it means that all the resources get destroyed along with that instance, so there's no cost associated left, there's no security risk associated left. We use semantic versioning and maturity ratings on all our modules. We're an ops team, but we use open source kind of principles in the way we develop our modules. We have full readmes, full change logs, and having that means that someone that's using it, they're not going to fall across anything that tricks them, and we try and, again, lower the barrier to entry to mean that people can adopt our stuff. With that, the fringe modules are an issue. So fringe modules, they might not be the best. They might not have our approval, or they might have been developed by someone that was just developing it, put it into our repository store, and they had something. It has been a problem. People have kind of deployed modules which aren't very good. So to combat that, we use maturity ratings, which go from high to low. They show whether a module is developed by the core team and is constantly in development, to low or without a tag, which is deprecated or we haven't tested it properly. So we try and make the choice easy for people to come in and use our modules. As Iain said, we use dry principles. It's pretty hard with the collaborative languages. It's very hard. And we'll always abandon dry if it means that we can have a nice separation. If it makes sense to us, then repeating code isn't too bad. And one of the biggest things, so Iain touched on the fact that we use kind of a puppet hero strategy. So every product has a control repository. So this is where they are only allowed to reference module imports and set up variables. So they're not allowed to do anything else in that. So it means that when we go into a repository, in a control repository, we know that there's no like kind of weird resource assignments in there. No one's kind of adding a security group that we don't know about. And with the module imports, everyone must reference a Git tag. So everyone sticks to a Git tag like you would in your Puppet file. You're not going to get surprises when you deploy. It's going to be solid. And with this, actually, with the approach, having the same kind of way to do Puppet as we do with Terraform and having it pinned and clear, it makes it easier for us to kind of chop between projects. We're not going to jump onto Science Direct. We're not going to jump onto a different type of project, and we're not going to be scared about what we're going to see. It's going to be the same pattern as we've had over here, the same pattern as there. Just makes it easier to spread out 20 people across all of these developers. So I'm going to go, it's just a core module example. So one of the ones that we developed, it's Jenkins. I'm guessing most people use Jenkins or something similar. So Jenkins is one of the most kind of widely used CI in Elsevier. But with any CI, there's a lot of wide variety of requirements that people want to put into it. So you'll have a development team, or you have a product that has front-end, back-end, client teams. They all have different languages, they all have different requirements, they all need different setups. So how do we cope with kind of designing something for that? And so what we actually did was we came up with two different modules. There is some repetition of code, but the advantages we get from that like heavily outweigh having one module that doesn't quite fit with everyone. And with that, we can have a lot of different deployment possibilities. So, for example, my Jenkins setup, I use Docker for all my builds, so I have a master only. So there's one module which is master and one which is slave builder. Deploys all the infrastructure for each thing. So for me, I just use the master. I build with Docker on the master. For bigger like platform Java teams, they're pretty heavy builds, so you can use the master module and then import the slave module once. For client teams that want to build on 32-bit, 64-bit, Windows, Mac, then what they can do is they import the master module once and they import the slave module a number of times. You're getting exactly the same infrastructure across all the slaves, but then using variables like your AMI ID and stuff like that, you can actually have different auto-scaling groups, so you can build across it really quickly and easily. So what does our platform library look like? This isn't a definitive list. There's a lot more than this. We have around 40 to 50 core modules. It's hard to count. We have a lot of different ones. So we have example deployment methods. So an application deployment is usually written specific for that application. There's too many variables to take in to write a specific rolling deploy or a BlueGene for every product we have. So we provide base modules for them to use. We also have monitoring modules, so we can monitor core Amazon metrics, so 500 instances in service. Really good way to wake me up at 3 o'clock in the morning. Really appreciate it. But it's the way what we're trying to do is we're trying to create everything so easy that we can automate a whole product's deployment with all the monitoring and everything in one place. And Terraform deploys the infrastructure, but how do we tie everything together? We use Puppet, so how do we tie into that, and how do we, tie into our AMI bakery? So somewhere on here, there's an AMI, there's Puppet server, and there's a user data module. So we have these modules that really kind of set up the flow. So the AMI module hits our AMI endpoint. It will pick up all the AMIs that are available for use. And then the user data template module, when you're launching your stack and you need a Puppet input, you reference that, and it means that the instances come up with the correct information and they bootstrap immediately through Puppet. It's just a repeatable, quick way to do it. And so what does it result in? Well, we can deploy environments really quickly. We can deploy environments in exactly the same configuration, and they will always have the best practice in, whether it be security or Amazon. And trying to lower the barrier, it means that there's a lot less work for ops in general to look after things. Developers feel empowered to actually empowered, but they can implement their own infrastructure and own it in a lot better way, and we don't have to worry as much about what's monitored, is it done properly. It's hard to show kind of what the results are. I could show you a huge Terraform file, or I could show you a big Jenkins output. It's not going to be very interesting. So just a couple of numbers. So this is a product that got deployed with our infrastructure a couple of weeks ago. So this is deploying 2 environments, and so we've got 23,000 lines of code. That's with the Terraform get, so that means that that's all the module output. If we actually do a max depth on that, it's only 2,500 lines of code, and half of that is setup, so setting up the variable kind of pointers and stuff like that. So it makes it a lot easier, a lot quicker, and a lot safer to deploy our environments in the same way every time. And that is it. Does anyone have any questions?
Have you done this across multiple cloud platforms? 3 or 3 currently, or 4?
Not,
Or 5, sorry, yeah.
Not yet, but I believe there's some plans to do that, and so it's within our kind of grasp that we're going to be doing stuff like that. So we're pretty prepared for doing it. There'll have to be changes for code, but as I was saying, like being able to use the same tool across multiple cloud providers means that the principles will stay the same, the code will stay pretty much the same. It'll just be different names.
Sorry, excuse me. Why you choose with Terraform, for example, not CloudFormations?
Provider agnostic.
Can you repeat the question?
Yeah, one sec. I'll get the microphone.
Okay, thank you.
So, what's the
Why
question?
Terraform and not CloudFormation? I mean, you can't do what we're doing with.
All right.
Just talking up. Networks.
Right.
No, we're not. Yeah. It's called catchbox. You can throw it and you can talk here.
Right.
Oh, well, that's
Who is
I
next?
think you'll give me the question.
So the question was, why didn't we just use CloudFormation? So it doesn't work across multiple cloud providers. That was the main reason. Personal reason, JSON is not something to write configuration in. It's something to receive information in, for me personally.
And for me, it's not manageable. If we had got to where we were, where we are now in CloudFormation, I mean, we have some customers who are doing this in CloudFormation. They haven't come over to us, or they started before we did have this available. And 3,000, 4,000 CloudFormation templates to do one thing, it's just unmanageable.
Yeah, we much prefer.
There's a duplication of copy and paste errors and duplication of code. It's
You mentioned that you use containers in for like testing and development for, I assume, to be able to bring down the modules and test them together with Compose or something. Does the service support it for developers, or is it just for dev?
Should never have said that. So testing our modules is something we really need to work on automating. At the moment, it's quite a manual process. So obviously we can run validations and stuff like that, but we need to put more wrapping around it. My Docker testing, my Docker stuff is more for AMI building and stuff like that. We need to work on a good way to do our testing. It's too manual at the moment.
Just throw it. You can throw it.
Don't mind anyone.
I've seen that design which I like the using Terraform with Jenkins. But my question is, how are you guys saving or even committing the TF stat files?
Say again?
I'll assume that you're not using Atlas. I'm not sure if you're using Atlas or not.
Oh, for the state files?
Yeah.
No, we use S3 at the moment.
Using S3.
Yeah.
So
we are talking with Terraform about Terraform Enterprise.
but how do you kind of like encrypting them before?
We're working on encryption at the moment. So at the moment, you'll have the state file in a private S3 bucket.
Yeah.
And the way the Jenkins job works is that there's a function that calls and brings out the state and makes sure it's there.
Somehow, if I got access over these TF stat file, I can see them like
If you got access to a state file,
Yeah.
fine. Yeah.
All right. Thanks.
At the moment, we'd need to encrypt it. It's an actual challenge around Terraform variables as well. So how do you inject secret variables in Terraform? It's a big challenge which we're looking to solve with Vault or something, but it's once you've got the whole Terraform structure in place, like we spent a long time doing this, and when you get to a point where you're stable, then you can focus on that, and that's kind of what we're moving to now.
Because I've seen a tool called TerraHelp, which people are using it to encrypt these files before committing, even using on GitHub. And so that it's kind of like the way you can access the set file to decrypt with TerraHelp, which is quite.
Yeah, so I think we're looking at. Am I allowed to say?
No.
Okay. No. Okay, nice.
Go ahead.
Am I? So we're looking at an encryption method that stores it in S3. TerraGrunt is actually quite a good tool. TerraGrunt, really good because if you're using Jenkins jobs, you're okay. But if you're doing kind of manual deploys, the locking mechanism is really hard. So you either have to create your own. TerraGrunt uses a DynamoDB for locking. It's actually really good to solve that problem.
Do you use Terraform to provision your users for each account, and do you let them have their own keys?
Sorry, I didn't hear that.
Are we using Terraform to provision users? So some products do. I created a way to do it. It is still pending which method gets chosen. The problem with Terraform is so we're a big organization. We have central authentication. So the ideal method is to tie into that. If we have the only way to do that with really Terraform through pure Terraform is to have a central authentication AWS account. And that doesn't really fit because there's still manual steps to remove someone from that account. So
the end goal for that will be ADFS integration, but where that will go, I don't know.
So question, with regards to the teams that you said 1,500 developers, something like that, various teams, when they need an environment, do you guys set it up initially and then give it to them and hand over? What is the process by which they go about actually getting this up and running?
So yes, we can, but we're a central team, so it's all about the engagement model for us. So basically, if they pay for us, we're happy to do it. Yeah, we don't care. We'll prostitute ourselves to anybody.
Everybody loves corporate horse.
Yep, that's the one. So they might pay for if it's a new product that's starting, they might pay for a project resource for a little while or whatever, in which case we'll do it. But the way we get around it, so that they will still utilize our code so that it's has all the best practices and all the right, the agreed patterns that are meant to come through, is we have a consultation arm. We have a consultation arm that, and we provide whatever sort of periodicity people want, but weekly is the most so whoever is implementing this stuff can come and sit for a week, come and sit with us once a week. We do code reviews with them, which gives us that feedback loop where they can talk about if they've got any requirements that they're missing and so on. And it's when we set up the team, we were very much I was quite keen on that we would be the implementers as well because it's the easiest way by a long way. Yeah, but the decision was not, and I think now I'm quite comfortable with that, and I'm quite happy. I think it's the best way. But it does mean there's more work for us to make it closer to that shrink wrap product, so it's easier and less, it's.
Yeah, with.
Follow-up, sorry. That's fine. So I was just going to say, the follow-up to that then would be, what do you think of things like Bitnami or other AMI building tools? I know they're going to be releasing all their tools for building images that are pre-packaged, that are all the modules are indexed, so you can get security updates. You know where it is. You know which services are running it. If you're building AMIs,
so we have a very robust and fully featured AMI bakery. That what it has a starts off with there's a few different OSs. People obviously give developers a choice of 6 OSs and they want to choose number 7. But they so we have a number of OSs which we then harden. We then have them linked up to the various different security advisories, and as soon as the security, then the bakery automatically spits out a new AMI, and that's our base AMIs for all the different OSs. And then we then do product AMIs on top of that. And it's just a chain on that. And then we then have an API endpoint that people can query. Those are shared out through the various accounts, and people can query those to see what the latest or whichever ones, the different things they want and so on. So we kind of do that. So some people, their deployment object is the AMI. So every time they build, they poke the bakery to create a new one. Sometimes, some of them it isn't. They do it through Puppet or whatever wonderful, ingenious methods they come up with. Does that answer your question?
Well, I have the box at the moment, but his follow-up question was my second question, so I no longer have a question. I just demand everyone feel sympathy for me. You're left with it now. You've got to ask one.
Yeah. Fast.
So, what was the reasoning for keeping individual accounts per team rather than going to a consolidated model?
Because this is
wonderful. Go on.
I mean, we're facing the same kind of place where I'm working at the moment, and they've gone for a consolidated, and it's in the transition phase at the moment. I was just wondering what your reasoning was.
It would be just too big, quite simply, and there are too many. Like I say, I can't actually sort of like discuss too much in numbers, but we would just hit so many AWS limits, Amazon limits. It would just be unthinkable. One thing, but that isn't why we did it. I mean, we have accounts which have very, very small spends of a few $100s a month, in them. So that's not why all of them are like that. There was a pattern from our infrastructure architecture people that we should have one account for production, one account for non-production. Each environment would have its own VPC, and there will be no VPC peering.
So to add with that, like the separation is based on the product to an extent because there's no peering. So if you're a product and you're not exposing an external API or something like that, then no one can link in with you, no one can use you unless so no one can kind of tie into your data streams and stuff like that. So it makes sense to an extent. Some of our products are huge. It would be nice to consolidate slightly, but we wouldn't be able to consolidate all the way. We would still have at least 70 accounts probably.
Cool, thanks.
Excellent. I just wanted to know, with regards to Terraform, you don't like CloudFormation. So with Terraform, how long has it taken you to create all of your modules?
We've been working on this for about a year, just over.
Just over, whatever. Yeah.
And so that includes...
And that is not full-time, and that is not very many people.
And so that includes, setting up all the kind of underlying infrastructure. Getting to use Terraform quickly. If you know Amazon, getting onto Terraform is pretty quick. Within a couple of days, I was pretty comfortable. That being said, if you're doing it at a big scale, it's nice to have someone that really understands it properly, failing methods and stuff like that. But to actually just get a handle on deployment is super quick. The documentation is great. And if you understand Amazon, it makes sense. The hardest bit in Terraform is understanding, well, I need this resource. What other resources do I need to make that work? Other than that, it's pretty just simple reading, for me anyway.
The default Terraform setup is it's all in one directory or one set of subdirectories, and you can just go for it, and your state files there. It's very simple. Doing it this way is a little bit more tricky, but if you've got one account or one stack or whatever to do it, then you don't need to go down this way.
And do you give permission to the dev teams to do their deployments via Terraform scripts or
through Jenkins? Yeah,
through Jenkins.
Sorry?
Through Jenkins.
Through Jenkins.
Yeah.
Cool.
Jenkins triggers Terraform jobs.
Yeah.
Excellent.
Because like Iain says, I don't want to be sat there doing everyone's deployments every day. So.
Excellent.
Any other question? No, I can't throw it anywhere. Now, is that one? Yeah, we have one.
So you slightly answered it there, but I was going to ask how are your developers interacting with Terraform? So you said it's through Jenkins. So with the variables, you have your Jenkins build jobs. You can set them in there, or
it's prioritized builds. So depending on what they're doing, we have various parameters in the build. If it's an AMI deployment, it's super easy. It's just one thing, and we hit a target module, and they deploy that target module. we had another job to control the rest of the infrastructure. We want to get to that position where we don't have to give developers access to prod. We're getting there. But having the Jenkins jobs, they have to deploy their stuff and they know when's best. So that's the way we do it.
Cool.
This is a long throw.
Don't let throw that far.
Thanks. So just quick question regarding Jenkins and Terraform. How did you store your secrets? Are you using the Jenkins store, or are you using Vault, or any other solution?
Secrets as in terms of getting credentials to run Terraform, or secrets are injected into Terraform?
Secrets used by Terraform, let's say, for example, the API key and stuff like this? Database
password and stuff like that.
Sorry, what?
So like a database password.
Yes.
Really not the best. It's on our roadmap at the moment. It's something that myself and an American colleague are working on. So we're looking at Vault to solve that. But as I say, we've not been working this year. We're now stable in terms of our module and our deployment. That's going to be the next thing. We had to to start with, the engagement was crap. So developers wouldn't want to know about us. They wouldn't want to use their stuff. So we've been working quite heavily on engagement, getting people to use their stuff first. Now we've got people coming to us willing to use their stuff. Now we can go off and make it better. That was the big task, I think. I'm a real techie, but I understand a lot more of that kind of work of late that Ian's been doing, driving into development teams to use their stuff. And that's, if no one uses their stuff, if our barriers to entry is too high or it's not good, I don't have a job. I can't. Oh, I've written this beautiful thing, but no development teams are using it, and so we've been focusing on that, and now we're going to be really improving it.
Okay, thanks. And one more quick question: are you also managing the Jenkins? So is there a global Jenkins, or do you have one Jenkins by dev team?
No. So dev teams launch their own Jenkins. It's the same engagement model. If they want our help, we will help them. We've got the example rolling deploy. We've got example modules, example public code to help them out. It's up to them whether they feel they can do it themselves or whether they can ask us for help.
And how do they deploy the Jenkins module since the build is made by Jenkins?
It's chicken and egg. So there will be an initial run from someone's laptop.
Okay.
That builds all the networking, and then you can deploy your Jenkins. There's no way around it.
Thanks.
Yeah.